So I always thought this one was kind of fun. What they're asking you to do is restrict the domain of the original function so that the inverse function will actually be a function, because as you can see, if we were to take our y equals x line here and then make the inverse function by switching, like, it's like when we talked about folding the paper and the ink is wet. So I'm folding the paper here now as if that were my axis on the y equals x line. And I'm going to fold the paper and press it together. Well, I'm not going to squish it. I'm just going to press it together. And then it's going to appear on the other side as if it was wet ink. So this 5 up here is going to go down here. So I can just extend my line a little bit, and my new point will be here. And you can see that this graph is just a little bit past 2 where it hits this line. So it's going to be a little bit past 2 where it hits this line, and then the same thing down here. So we're switching our x and y axes, and that's the whole point of the inverse graph, is that you switch your x and y values, which you already know by now. So what this would look like is I'm going to have a curve that goes out like that, so that squishes together along that xy line. But this isn't a function, because if I use my vertical line test, then I'm going to see that I've got 2x values for most of my y values. So it hits the line twice all the way along. That's not good, because what I want is for it to actually be a function when I flip it. So what can I do to the original graph to make it a function when I flip it? Well, I have to get rid of one half or the other, right? If I got rid of this half, then it would just be that part getting flipped. If I got rid of this half, then it would just be that part getting flipped. So if I cut it in half vertically and discard one of the halves, then when I flip it, the only thing left is going to be one of those halves, which means it should be a function. So in order to do that, basically your book, sorry, I was just reading through your book to make sure I didn't miss any notes, but your book goes through kind of a long, extensive, blah, blah, blah. We're going to switch the formula around and everything, but I could just look at the graph. And when I look at this graph, if I made all the x values not happen on this side, then the flip would be a function. If I made all these x values on this side not happen, then the flip would be a function. So what I want to do is I'm going to restrict my domain to x has to either be greater than or equal to 0, or x has to be less than or equal to 0. So I can do either way, and that will work. If I made it x has to be greater than or equal to 0, then all I would have in my original graph would be this part. And when this part gets flipped, it's going to be, it would look like this. That part of the graph would still exist. But the part that my hand is covering up would not. If I made it x is less than or equal to 0, then only this part counts. So only this part would be reflected, because those are symmetrical over the y equals x line. So when they're asking you to restrict the domain of the original function so that your inverse function is an actual function, all you're really doing is you're looking at your original graph and taking out the x values for half of it, so that when it flips, it's only half of a parabola instead of a whole parabola.